Hi, I'm going to talk about StartLine and the RaceBox that goes along with it. This is the RaceBox. It comes in many different configurations that you can build up. The simplest one just takes NEMA data from your instruments, processes it, makes corrections on all of the inputs. You can correct the log sensor, you can correct the wind position, the wind vane, and sends it to Bluetooth to the StartLine. So here is StartLine running, and the way you would get this going is you hit the NEMA button and you hit start, you find the RaceBox, and it connects to it. See, it's connected to Papoose. And then from there you can go into an instrument display and you get the readings. In this case I've got some simulated data coming out, 7 knots in the heading, and these can be used in things like you can display the instruments on an instrument page. You can go into wind and current, set the wind, and you can use the actuals, and it'll use the readings. So it's very useful. But that's just one version. As a base, you can add options to it. One of the options is the heel sensor, which I'll show you in a minute. Another is the ability to drive a stow display, and for that I'm going to have to reposition the camera. So here you have the stow display here showing, in this case, the default, which is speed, the true wind speed, the current, and the true wind direction. But the beauty of this display is, if you go into say the start mode, it changes.
And check the data screen.
It switches to the start data, where the time to start, the ley line burn factor, and the line burn factor. Or if you're in the race screen, it switches to the turn, the speed, the wind shift, where you're headed, the next mark, and the current. So, and these can be, you know, if someone has a particular interest in,
Did you align the prop and check
let
the
me
data
get
screen?
back to instruments here. Somebody has a particular interest in a set of readings, anything can be customized. And here is the default when you're not on one of either the start screen or the race screen. Oh, I should say you can also ping the marks. So if you have a mark, it'll tell you the mark, it'll tell you the distance to the mark. I don't know if you can see that. So that's one of the options. So you've got the heel, you've got this. The next option is a GPS. So an internal GPS, it goes out to Bluetooth. There's a program that is Bluetooth GPS provider, where the author has worked with me to develop a way to interface that with the RaceBox, so that with StartLine, so that you can get the GPS data plus the NEMA data both in through one Bluetooth channel working with StartLine. The other thing is you can use a hub, an external hub, and you can get multiple, in this case it's set up for 2 inputs, and that's you can do that with the standard version. In my case, I'm going to use that to get the depth data off my smart depth. So I'm going to demonstrate the heel function, and for this I have set a display, not a normal display, but just one to display the heel number. You can see that it's bouncing around a little. This table's not too steady, but here's a 30-degree triangle, and if I put that in there, it reads around 30 eventually when it settles out. And when I take that away, it goes back down to around 0. So this can be used to make some corrections on the leeway. There's some formulas for that, and it also just is interesting to see what your heel is when you review your race results. All right, now that I've shown you what it can do, let's look at what's inside. Let's disconnect. This is the full-blown version. It has all these features that I've mentioned, but that's not necessary. You can do simpler versions, and I'm just going to try to zoom in on this a little bit to show the different parts. If you start with just the Edison itself, you can use just this. This is the Edison, and put the NEMA input here, and that's all in power. So you just do that, and you can do all of the calculations and corrections, and you can do Bluetooth out. You don't, if you put it in a plastic box, you don't need an antenna. If you don't, you need an antenna like this one that I took off. So that's the first level. The next level, you might want to add the heel indicator, and that is this accelerometer. That's as close as I can get. The accelerometer, I'll point out with this, is this little tiny board here, this little interface board, and if you want to interface with the stow display, you need an RS-232 converter in order to send and receive the signals. But that may not even be necessary, because really the NEMA port could send data to the display as well. If you wanted to do that, I just modify the code to accomplish that. Next is adding the GPS, which is over here. And all of these steps are optional as features. With the GPS, I interface that directly to the Edison, and I have this other board here that has the an RS-232 read, so read the keys off the display. So a little bit of change in the code there, but again, this can be customized to anybody with just little switches in the code. So the box itself has the putty connector, which is optional. It has a power switch, if you want it. It has a fuse. I have a 1 amp fuse. And it has a feed through to get the NEMA input out. There's 2 antennas in this version. There's a GPS antenna, and one of the advantages of this is a very good GPS unit made by Adafruit. It's the latest chip. It works great, and it can use an outside a remote antenna if you want. You can use the antenna that's on it, but the remote antennas are pretty cheap, and they produce stronger signals. And then the Bluetooth and Wi-Fi antenna port, the GPS, the 12 volts goes in there. The putty interface and the on-off switch, and here's the connector to the stow display, and then the NEMA input. So that's the insides. Again, different levels. Just the Edison plus some circuits to give the heel and the input to the stow display, and then the last addition I did was add the GPS, which then can talk to the tablet, and you don't need to use a puck, another device.